go ahead and do it.
one of the recommended things, but
I don't remember that one, but I know the most common one we did, I did it 2 years in a row, was Letter from Birmingham Jail.
yes.
We did the last two.
And that's one of my favorites. And then we read, for April, we read like Just Mercy, which is all about the death penalty. It had the movie come out 2-3 years ago with Michael B. Jordan.
I'm not sure about the movie, but I know one of my teacher's classes read the book.
I recommend it because it
Ready to go.
really opens your worldview and you're like, oh crap, you know, this is a problem.
I'll have to read it.
We had to read a book about like this college guy who was just like, my childhood sucked. Here's the story, and it was just
Oh.
like this long, convoluted story of him moving back and forth between New York City and Iowa, and like all of his siblings dying of malnutrition and stuff. It was just really depressing.
But it does, I don't know what it is with English teachers and depressing books. Like
Yes.
I had to read Into the Wild, which is
We read
basically,
that too.
yeah. All at the beginning, I still kind of think of it this way, but at the beginning, all of my whole class was like, is this just a long-winded suicide attempt?
I mean, he was a crazy man.
No.
I think this story is really interesting, but I didn't like the book because I felt like the author just made it so much about himself for no reason. Like, there was so much of him being like, I connect to this and I understand him and I'm the only one that gets it. And I was like, okay.
Especially the chapter about his own, like, Alaskan mountain.
Yeah, I was like, I understand that, like, maybe there's not as much like story there as like there would be with, like the unique for a whole novel, but that doesn't just mean that you should just like put it in a book. Like, because there were so many random stories that didn't like really have that much to do with it. And I was like, okay, yes, like, all right.
We didn't read a lot of full-length stuff. We read a lot of shorter stories. And my teacher said, when you take these home, if you tell your parents about them, make sure you also say that I'm not crazy. And so then we were like, oh, Mrs. Johnson, you're not crazy. And then we started reading them, and we were like, Mrs.
No
Johnson,
way. I did too.
this is wrong.
That's funny.
And she said the dark stuff is just deeper and it's good.
Oh.
Let's do a quick little social experiment. How many, raise your hand if you're from Oklahoma and went to like primary school here, like high school and elementary. Okay, just sound off real quick. What school district? Like what town? James.
Edmond.
Yeah, of course.
Hydro, Oklahoma.
Okay.
Keys.
Jeez.
Diamond.
Lawton.
Lawton. Okay. Anyone Oklahoma City? One. Huh. Yeah, kind of weird. Kind of weird that in the honors section there's only one person from Oklahoma City, right? Might be saying something about the Oklahoma City Public School District.
Are there more Oklahoma City?
Oh, yeah. My wife has been a public school teacher in Oklahoma now for 7 years. That's why I moved out here. And she worked in Oklahoma City Public Schools in like the inner city. I was just listening to all of you talk about like having books. And I was like, wow, you have books in Oklahoma. Crazy.
I just met
Because they
Arthur.
didn't have books. Literally. They didn't have textbooks. Crazy.
I mean, we have textbooks, but it's like, it still has Yugoslavia on the maps, but we have books.
Yeah. I remember she was teaching social studies and histories her first year, and like they literally they just got rid of the textbooks and just didn't replace them. So she had to make her own curriculum. I was like, wow, that's really crazy. Anyway, not to shit on OKCPS, because I think public education is a bigger problem than any particular school district in this state. But anyway, I was just curious. Before we get started, any questions or anything? Anything we want to go over? Logic, Hume's problem, anything we've covered so far? All right. Nothing? Concern?
Share something.
Go ahead.
Okay, so I found this thing. It's probably a very basic logic, but it still blew my mind. Because it was the sentence, this sentence is false. And then it was like, wait a minute. If that's true, then it's false. And if it's false, then it's true.
Yeah. The liar's paradox. Yeah. if you have a sentence that says, this sentence is true, or this sentence is false, and then if it's true, well, then it's false, and if it's false, that's true. So you have to find some way out of that. That paradox has really motivated a lot of developments in philosophy. I mean, people have tried to solve that for a long time. I still don't really know exactly how to solve it, like to make sense of it. I just ignore it. I just ignore most paradoxes.
I think that one just like, maybe it's just a paradox that's kind of let in by like the English grammar. Like it doesn't necessarily like, just because it's grammatically correct doesn't mean it actually makes any sense.
Yeah, it arises in any language that has a truth predicate.
Really?
Yeah, by truth predicate I mean a truth value system, right? And it seems like all human languages speak in terms of true and false, right? That, at least that I'm aware of. So as long as you can take a sentence as your subject, like this sentence is a subject, and then say it's either true or false, the paradox will arise. So as long as speaking of sentences themselves as subjects and predicating them of a truth value, you've got that paradox, and it's not exactly clear exactly how to solve it. One way of solving is just to say, well, it's gibberish, it's meaningless, because this sentence doesn't refer to anything. Because it's not like you're saying this sentence that describes something is false. But then, doesn't it refer to something? It's referring to itself. But then what's it saying is false? And then you have to have a theory of truth or falsity. Oh my God, it never ends. Yeah, so many paradoxes in philosophy. And not exactly sure how to solve most of them. Thank you for sharing. I like it.
Well, it blew my mind, so I wanted to blow everybody else's.
Yeah. Yeah, you should just look up like philosophical paradoxes and have your mind blown. Like the whole thing about motion, like Zeno's paradox. If there's a line, right, and you're going to move from point A to point B, you have motion, right? Anybody ever heard this? You have motion from point A to point B. Well, but you can divide this line in half, right? As you say, to get to B, you have to go to C. Well, but you can divide that in half. And you have to go to D to get to C to get to B. And you can divide anything infinitely, right? So then you have to pass through an infinite number of points to get here. How can you pass through an infinite number of points? Wouldn't that then take an infinity to move? So how does motion work? If there's an infinite number of points between A and B. Yeah, so Zeno at that point said, well, motion's not real.
Is that the one where it's like if you like take a distance and then you do like half and then like add on half of that and like you keep going, then you're moving an infinitely like small amount until you like never actually reach the end point because
Yeah, right, exactly, yeah. Because, I mean, you can just infinitely divide a line, right? You can infinitely divide numbers just into little more slices. So, yeah, so many things like that, and they give rise to entire philosophical theories and systems. It's crazy. Yeah, Zeno thought, because of that, Zeno thought there was no motion, and thus everything that existed is actually just one thing, and it's not really moving. We're just parts of this one thing, this monad, right? So all of existence, God, human beings, they're all actually just one big creature that maybe has changes inside of it, but change is still an illusion. Interesting. Anything else?
That guy actually believed that, or was he just really high on something?
Oh, absolutely, you believe it. I don't know if they got high back then, like on recreational drugs. I mean, humans always have, but like, yeah, no, I think he believed it. It's a pretty well-developed system.
Wait, why
People
is
still
that?
believe that stuff.
I can't believe that anybody would actually think that and be serious about it.
Nope, there's fundamentally no way to disprove a lot of these things.
Like, why does that make any more sense than just like, I'm moving my hand right now and I can see that that's happening?
Because you can't explain what that means. Can you solve the paradox?
I can't explain us being one organism either.
I mean, but it makes sense, doesn't it? Like, do you understand what it means for all of us to kind of be one organism? Do you understand what it's like to be deluded, or to have a hallucination, or be under an illusion?
So wait, so the theory is like we're just all like hallucinations of this like organism?
not necessarily just hallucinations, there's some sort of illusion going on, illusion of change in movement, but there's not really change in movement. And if that sounds weird, think about how probably like half of neuroscientists and psychologists think that consciousness is an illusion. Consciousness isn't real, but isn't that just obvious? Well, if the consciousness is reduced to your brain, then it's not a separate thing, but it feels like a separate thing. So how do they believe that? Ooh. Yeah, there's also some weird stuff. I mean, philosophy and psychology, anything that starts to get into metaphysics just gets really weird really quick. And it just seems so bullshit, right? But then you actually start thinking about it like, oh God, I can't exactly point out what's wrong with this. But I'm not like that. I'm more of like a practical sort of guy, like Aristotle, who believed that there's many different irreducible types of being. And it's way more complicated than any of those. Anyway, anything else? Okay, well, let's get into 7.1 and not have my speaker feedback. Who's done 7.1, or at least read the chapter? Have most of us? Okay, good. So 7.1 is introducing really the core concept of what I think is most important to learn about symbolic logic, and its proofs via natural deduction. So, okay, ignore the proof part, just focus on what natural deduction means. Natural deduction is, shut up, oh God. Natural deduction is a system for doing proofs or inferring conclusions or making inferences from premises that more closely follows the linear step-by-step way we do it when we give an argument in a debate, right? We've had truth tables, and you can prove an argument valid or invalid with a truth table, right? But I think we can all see and agree that's not very natural. It also takes a long time. So there's got to be a better way to do it that, one, more closely reflects the structure of our natural thought, of how we actually reason and argue with each other, or prevent evidence that goes to a conclusion. So that's the first thing that we need. We need a more natural way of doing things. Two, we need something that's not going to take so long that we have like 32 or 64 lines of a truth table. And that's where natural deduction comes in. So what natural deduction does is it says, okay, here's a model of how human thought works. When we give a deductive argument, we start with a series of premises. I've modeled this for you 5 million times already. And we derive from that, which I'll now put with slashes, some conclusion. Well, unless we're going to unpack every single assumption, every single step in our argument, we're not going to have all of the steps. There's still going to be a little bit of a gap between premises and conclusion. So let's give an example of an argument and see how that works. Okay, let's say premise one. I'll go back to an old favorite example. We'll say cats are mammals. Actually, we'll say cats are felines first. Felines are mammals. Then we'll say all mammals can lactate. Right? Lactate means produce breast milk. That's what being a mammal is, right? At least that's how it used to be defined. There's probably some weird genetic basis for it now other than just having mammary glands. And then, so I can conclude from this that cats can lactate. Right? And I'm talking at the level of a species. I'm not talking about individual cats. There are obviously male cats that can't lactate. Okay, but I've got my argument, I've got my premises, my evidence, I've got a conclusion. And we could all pretty much understand this. But there is a little bit of a gap here. You're spewing information at me. You're saying cats are felines are mammals, all mammals can lactate, and thus cats can lactate. The point of natural deduction is to eliminate even the tiny gaps here between the premises and conclusion. Now, if I was going to eliminate those gaps, what I would do is I'd put a line. What's this line represent? That's a conclusion this time. But what's the line? Does everyone remember? Inference. So anything below this line, I am inferring from the premises above it. Now let's just say, I'm just going to say 4. And I'm going to basically draw out the content of the premises to fill in these gaps. What could I put for 4? Does anybody have any ideas?
Cats are mammals.
Yeah, okay, so I can combine premise 1 and 2. Right? And I can say cats are mammals. Everybody see how that works? Cats are felines, felines are mammals. Combine these two things, what do I get? Cats are mammals. Trivial, right? 5. Now what can I do?
Felines can lactate.
We could also do, yeah, felines can lactate. Good. There might be many different ways we can get to the conclusion and fill in the gap. So let's just say, what lines would that be combining 2 and 3? So felines are mammals, all mammals can lactate, felines can lactate. Good. How do I get my conclusion?
Combining 4 and 5.
Well, cats are mammals, felines can lactate. Does that work? Not quite.
Be 4 and 3.
4 and 3. Cats are mammals, all mammals can lactate. Thus, my conclusion, cats can lactate. Which would be 4, 3. Make sense? Now that's my conclusion, right? I just filled in all the gaps. So I mark it with my 3 dots, maybe I do another line and I write here, valid. I just proved that this conclusion necessarily follows from the premises. Making sense to everybody, this technique? Any questions?
What's that, line under 3?
The line under 3, this is the line of inference.
Okay.
So it just shows that anything below this line has been inferred from the things above it, the premises. Yeah. And then I wrote another one here because we inferred that, and that just marks that this is the conclusion. Is this pretty straightforward? Is this straightforward enough for everybody? Any misunderstandings, any questions? All right. How can I translate this? Let's just go, this isn't exactly right. But let's just say, if it's a cat, then it's a feline. Premise 2. If it's a feline, then it's a mammal. Premise 3. If it's a mammal, then it can lactate. Conclusion, if it's a cat, then it can lactate. Right? And then I start proving this. But my goal is to step by step, again, derive this conclusion just from assuming these premises are true. How do I do that? What do I need to do?
Rules of implication.
The rules of implication, or the rules of inference. I like to call them the rules of inference because, never mind, technical reasons. But yeah, rules of implication, rules of inference, where you either combine 2 premises and use a rule, or you take one premise and use a rule on it and change it into something else, right? So, what are our, where's my eraser? What are the rules of implication that we have learned so far? Somebody want to give me a list?
Modus ponens, pure hypothetical syllogism, and then disjunctive syllogism.
Modus ponens, modus tollens, hypothetical syllogism, disjunctive syllogism. I make sure the camera's picking up that side of the board, and it is. Good. Okay. These rules of inference from 7.1, what are they? Somebody tell me what these are. Not like what the form of them is, I'll get into that in a second, but what are these rules doing for us?
They're like the fill in the gap parts. So that's what our brains are doing automatically that we formerly couldn't actually describe.
Good. Yeah, they are patterns, we could say. Patterns of what? Of inference. But what kind of inference? Starts with a V. Valid. Yeah. These are different patterns of valid inference. So let's say I have modus ponens. I'll write it with shapes. Square then triangle. Square. What can I conclude?
Triangle.
How do I know that? How do I know this is valid and good? Why is this good? Think back to Hume's problem of induction. He says, can you explain to me why inductive inferences are good? Well, can you explain this?
If square is sufficient for triangle, then if you have square, that's sufficient for having triangle.
Just by looking at the meaning of what this operator means, just by understanding the meaning of premise 1 and premise 2, you see that this conclusion follows in an intuitive, self-evident, obvious sense, right? Now we could put these in truth tables, and we can verify that, yeah, that does follow. This will always be valid. But that ultimately gets back to the truth conditions of the operators, and so it ends up being a little bit circular. So the easiest way to think about these, all of the 18 rules of inference we're going to learn from 7.1 to 7.4 are patterns of valid argumentation or inference. And with natural deduction, what we're trying to do is we're trying to take some argument form like this, and we're trying to use the patterns of valid inference on the premises to derive the conclusion. Now, if we know all of these rules are good, they're trustworthy, they're reliable, they're valid, and we're assuming all of our premises are true, and we're able to derive the conclusion, then that's a way to prove the argument is valid. Because every step of the way, the premises are true, I'm using obviously valid patterns of argument or inference, and that allowed me to get my conclusion. That means the conclusion is always going to be true when the premises are true. It's going to be trustworthy, reliable argument. It's going to be a valid argument, right? Now that's, of course, independent of whether the premises are actually true. It's hypothetical, right? Just validity. Does that make sense? Generally what we're doing with these rules? Any questions on that? Okay, modus ponens, which literally means affirming the antecedent. Yeah, the antecedent. Antecedent, consequent, or what comes before, what the consequence is. Sufficient and necessary. If square is sufficient for triangle and I have square, that means I have to have triangle, right? No duh. If triangle is necessary for square and I don't have triangle, what's that mean? I don't have square. I'm running out of room. Hypothetical syllogism. Called hypothetical because it doesn't actually commit you to anything in particular. It's purely hypothetical reasoning. If I have square then triangle, and triangle then circle, what can I conclude from that?
Square then circle.
Square then circle. All cats are felines, all felines are mammals, thus all cats are mammals. Everybody see why this is a good way of arguing? Valid? And then finally, disjunctive syllogism. I have at least one of these, square or triangle. I don't have this one, so what am I left with?
Square.
Square. And that can be the same the other way. I have square or triangle. I don't have square, so what am I left with? All right. This is basically just the process of elimination, right? Okay, boring, obvious, self-evident. Any questions on these?
I did have one question just from the reading.
Yeah.
I've got
ignore
And
that.
it seemed really evident that you could just,
Right. Yeah, the book is stupid. I don't know why the book doesn't just define DS this way, where you can, if you have, one of them, if you don't have one of them, then you're left with the other one. They want you to instead switch the order. So let's say I have square then triangle, sorry. I have square or triangle, and I have not triangle. Well, they want you to first switch the order of this to triangle or square, so it lines up nice and neat. Who cares, right? Who cares? It doesn't matter. What matters is the content, right? And this content makes sense to you, right? So I don't care if you use that commutativity rule, which we'll learn a few chapters from now. Go ahead and solve it. Use it like this. If you don't have one of them, then you're left with the other, no matter the order. And that kind of gets me into my next point. I do not care if you know the names of any of these. I really don't give a shit at all. What I care about is that you understand what these mean. And it shouldn't be that hard to understand what these mean, because for the most part, especially these ones, are just super obvious and self-evident. And we reason like this all the time. But even the more complicated ones that we'll learn in 7.3 and 7.4, you have to think about them and look at examples. But once you grasp their meaning, it should be something that sticks and that you could trust it. So as long as you understand the meaning and can tell me exactly what moves you're making in a proof, I don't care if you remember the names. It's great to remember the names, you should try, but the important thing again is the meaning. Make sense? Okay. I guess there's one more point on that. Do not try to play with shapes. Do not try to look at this and basically be like, I don't know how to put it other than to compare it to math. A lot of people are bad at math because they're not actually taught the concepts. They're just taught to imitate teacher, right? The teacher starts putting up addition problems and the kids start picking up on these patterns of, well, when there's something that looks like this, then I say something else, right? They don't actually understand the addition function or what these numbers are. And that's why teachers should use base 10 building blocks or count on your fingers or do groups, right? So you have to teach concepts, and kids can pick up on this quick. But then what you'll see, like in my wife's class, she teaches math now, is they'll be getting this stuff because they're just imitating and memorizing the pattern. But then when you give them a bigger addition problem, even if they've mastered up to 10 or even 20, you give them bigger ones and they literally do not know addition. If you just look at the patterns here in the visual form, you're not actually understanding the content, right? This is just all of symbolic logic, including these rules. It's a visual form to something that is not material. It's mental. It's conceptual. So don't rely on these as, if you memorize the picture in your head of all of these, that you'll do good. To do good at this stuff and to understand it, you have to understand the meaning of each of these. Now, does anybody not understand the meaning of any of these rules? Do I need to describe them or explain via example? Raise your hand if each of these rules makes conceptual sense to you. Any questions before we move on?
So on modus colon, right?
Mm-hmm.
So if you have square and a triangle and you don't have triangle, you don't have square, but doesn't that like not make that much sense because you could have, aren't there other possibilities that square could mean something else?
Mm-mm. So think about the meaning of the conditional, right? So if I say P gives me Q, what does that mean? If I have P, then I have Q. So that's one part of its meaning, but there's other parts of the meaning too. That's just one little bit. So this is sufficient for this. Well, but if every case, let's put it this way, if whenever I have P, I'm guaranteed a Q, could there be a P without a Q? If every time I have P, then I have Q? No, because if I had P, then I would always have Q. Well, so then we say Q is also necessary for P. So if I don't have Q, then I don't have P. Does that make sense?
Yeah, that makes sense.
Yeah, so there's the meaning there. And that's exactly what I mean. You could not understand this rule, and you could just look at the shapes and the format and try to copy it. Or you could, and I guarantee you and other people will have to keep reminding yourself of what we just said, right? To really drill this in. But yeah, understand the meaning like that. Necessary and sufficient conditions.
I'm a little confused on like the sufficient part of that, because I can understand like necessary, meaning implying that like if you have P, then you must also have Q. But with sufficient, it's like, I guess, I mean, you could say, if you take a prerequisite class, that is sufficient for you to take the next class. Like in that example, just because
I think you're getting them mixed up. So on the left is sufficient, on the right is necessary.
Right, so let's say on the left I take, I don't know, pre-calc. I have to take pre-calc before calc. I take pre-calc. That doesn't mean that I necessarily have to take calc afterwards, right? Because I could take
Right.
pre-calc and that be the last class I take.
But that's a prereq, a requirement. It doesn't mean it's sufficient, right? So that's necessary. You taking pre-calc is necessary for you to take calc,
Okay.
but it's not sufficient. So this is just necessary for this.
Okay,
So-
in that example, then calc would be sufficient for pre-calc? or-
Yes, yeah, exactly. Calc, pre-calc. It's not that if you take pre-calc, you move on to calculus. Maybe you take it, pass it, and hate it, right? And you're just like, I'm changing my major. But if you did take calculus, well, that means you must have taken pre-calc before at this school, right? Does that make sense? Yeah. It's just like, again, my favorite, cat and mammal. Man, I'm going to get so tired of this example. I used to do eating eggs, eating breakfast, and then I was like, that's even worse. I've done that a few times, but that was my go-to. But now cat and mammal. Is cat sufficient for mammal? Yes. Is mammal sufficient for cat? No. But mammal is necessary for cat. So if you're a cat, then it must have been that you're also a mammal. But it doesn't go both ways. Does that make clear that? Yeah. It's hard. The necessary and sufficient condition thing is like, there's a lot of meaning rolled into that one symbol, right? Okay, any other questions? Are we good on these? Okay, now let's do the proof. Using those rules, what can I do here? Multiple approaches.
I would do hypothetical syllogism first.
Okay, what lines?
You could say like C then M for lines 1 and 2.
Okay, so 1, 2, hypothetical syllogism. And that gets you C then M. Yeah, because C then F, F then M, you could kind of think of, I don't recommend this, but if it helps, you can think about that C and M are linked by a common term, right? I prefer to think there's a chain of sufficiency here. C is sufficient for F, F is sufficient for M, so therefore C would cause F would cause M, C would cause M. Or C would be sufficient for M, right? But whatever helps you, whatever floats your boat. Okay, good. So we've got C then M. Next step.
You could say C then L because 3 and 4.
3, 4. Hypothetical syllogism. Good. And so we've gone C then M, M then L. Again, it doesn't have to be in that order. You have to have the content. So you could see like square then triangle, triangle then circle. It's actually reversed here. It would be triangle then circle, square then triangle. The order doesn't matter. The important thing is that you know the content, if that makes sense. So yeah, you get C then L. So you proved your conclusion follows from the premises using perfectly self-evident and reliable rules of inference. And you can conclude that it's valid. Good. Making sense? What's the other way we could have done this?
Could have done F then L.
Good. F then L. 2, 3, hypothetical syllogism. Then what?
Then you could do, you have to be able to do C then L, right?
See the now, good. 4-1 hypothetical syllogism. Which way is better?
I think the previous one, since it's more of that chain and it's not just going back and forth.
Sure. There might be a clarity to it, right? And there might be, so there's a couple of things in the proof that you look for. You look for clarity and you look for simplicity, which, just get ready, because the last few weeks of this class, when we return to induction and probability, all of these are going to be big concepts. Think of simplicity as the least number of steps or the least number of hypothetical things you posit, the better. Occam's razor, right? The simpler you can do something, the better. Clarity. It doesn't just have to do with simplicity, because if you read a math book or any book in like advanced logic and you look at it, the freaking idiots that write these books, they're so smart and they're so stupid. I hate them. They write these books where they will prove some logical or mathematical theorem, and they'll do it in the simplest possible way. The problem with that is the simplest possible way is not necessarily the most clear and easy to understand. So we want to do proofs that kind of have both of these wrapped up, right? We want to balance clarity and simplicity. That being said, the first way was more clear, I think, but they're both equally simple, 2 steps, both using hypothetical syllogism. But that's not wrong. They're exactly logically equivalent. In fact, part of the reason why so many people don't go into advanced logic or the history of logic is because all logic, if you want to be as simple as possible, you can reduce all logic to 2 operators, not and and. And you could do everything we're doing in this class with just those 2. Problem is, it becomes really unclear, even though it's really simple. But it's technically right. It's equivalent. So keep clarity and simplicity in mind, but this and the other approaches to doing proofs, they're not wrong. So yeah, in one sense, it's better to do something in the simplest, most clear way possible. In another sense, this is perfectly good, as perfectly good as the first one. Making sense? Okay, so what if I give you an argument like this? Okay, my conclusion is what? Y and T. My premises, 4 premises. Let's just read through them real quick, and then we'll take a vote on whether it's valid or invalid. P then Q, not Q or R. P, R then Y and T. Therefore, Y and T. Valid or invalid?
Invalid.
Raise your hand if it's valid. Raise your hand if it's invalid. What were you going to say?
So we can see we have P from line 3, and so that takes us to line 1. So P then Q, but then to get R for line 4, we have to have not Q, but we do have Q, so that invalidates line 4.
What's your proof? Let's see. Let's see who's right. Again, raise your hand if valid. Raise your hand if invalid. This is going to be fun. I mean, I could be wrong in my guess. I'm not going to tell you what my guess is here. But I'm just going to show you step by step how to do this. Okay. I've got P. I've got P gives me Q. So I know 1, 3, what rule? MP, modus ponens. Again, you can call it, this literally means the mode of affirmation. Affirm this gets you this. Modus tollens means the mode of denial. Deny this gets you a denial of this. You can call it affirming the antecedent or affirming the consequent from MP. Okay, so I've got Q. 6. Now I can do 2. I'm going to combine 5 and 2. With what rule does that look like? Disjunctive syllogism. This means I have to have at least one of these, right? But I don't have not Q. I have Q, right? So get rid of that. And what am I left with? R. Yeah. Tricky. Well, now that I've got R, I have Y and T from 4, 6 modus ponens. And there's my conclusion. Most of the class was wrong. Isn't that fun? Imagine giving a complicated argument in philosophy or in anything. I mean, you can use this in law, you can use this in history, in any of the sciences you use arguments like this. And if you really want to get clear on your arguments, you will put them in, at the very least, in standard argument form, and in your head do a proof of them, if you want to get really clear. But when you get complicated arguments going on, human beings, like, we can't just see that quickly. We have to spell it out step by step in our heads. That's why this is so beautiful to me. I love natural deduction. This is my favorite. This is one of my favorite things I've ever taught, but also a favorite thing I've ever learned, I think, is how to do this. Okay, does that make sense? Why that's valid?
So with that proof, it's sufficient to just put Q. You don't have to have not Q. So I did that sometimes in the book.
That's another thing in the book. Just a stupid another thing. The book likes to say, if I have, let's say, P or not Q, and I have Q, well, that's the opposite of this, right? So I should just be able to say P. But the book will go, no, you need not Q.
It seemed less.
But it's the same thing. It's stupid. Yeah, just ignore all that stuff. Again, the reason you're finding that is you understand the meaning of what's going on, and you're not just playing with shapes. If that makes sense. Questions?
Can we do some homework problems?
Hell yeah. That's what this class now is becoming. Homework. Yeah. And class participation in homework. Which problem did you want to do?
Any one would be fine.
Can we do 6?
6?
Yeah, 6, 3, 5, any of them.
Okay.
Honestly.
So you'll have, I didn't see who suggested 6. You'll come up and do 6 right now.
Oh.
Then you're going to do 5. Volunteers? Is that the number? You're changing the number.
I'll do 3.
You want to do 3? You'll do 3. So 6, 5, 3,
I'll do whatever.
8,
Sounds good.
6. Remember your numbers. 6, 5, 3, 8. Come on down, number 6. Let's do this.
I feel like we're on crisis right now.
Yeah. This is where the class gets fun. I mean, this is it, guys. Until we get back into content with, like, induction and probability and stuff like that, this is the rest of the semester. And I just get to sit back and watch. So this is 7.1, 7.1.1.
That's how I like to title it.
Oh gosh. I don't know the date the packet is due. No.
It's sometime in November.
Is it really that late? That's crazy.
Yeah. I think it might be like November 9th or something.
That sounds about right to me.
Okay, so in the book it says, it gives you like the premises, and it says derive the argument and then justify it with proof.
Okay. And keep in mind, again, as Noah's pointed out twice now, some of the rules of the book is really stupid and restrictive. So you might be able to do multiple derivations. And if you can get more than one, it's fine. The book specifically says you can only do one. Who cares? Like, just ignore that. You can do multiple if you want, right? There's multiple right answers here. Okay. Do you have any idea what we can derive with those 4 rules?
I did the question, I didn't answer, but I'm looking at it, I'm like, I don't remember exactly what I
It's okay.
Some days ago.
So what's the first step of deriving something?
Okay, so first we know, wait,
Oh, one step back. Procedural step. Has to do with a line.
do we need it?
Line of inference, good.
Okay, so we've got, should I put 4 here? Or
Yeah, 4 is fine. Or you could do 5, it really doesn't matter.
So if we have S then J, but we have not J, then that's modus tollens, right?
Right.
So we can say not S, 3, 2, modus tollens.
Okay, good.
I put and P, but I think that's wrong. I think it's just this.
And P. Yeah, oh, you were trying to do disjunctive syllogism
Yeah,
on 1 and
I did
2.
it the wrong way. Yeah, so I think it's just this.
Someone describe why can't you do a disjunctive syllogism on 1 and 2?
Because it would be true with the
Good. Yeah, exactly. Thank you. Like, that's a perfect way of saying it. Both would be true. You have to deny one of those to get the other one. Okay, good. So now I want you to do something real quick. I want you to go to 1. I want you to erase the tilde from J. Okay, now I want you to erase P. I want you to put parentheses after or. I want you to then say X and Y. Okay, now I want you to derive one more thing. I want you to derive one more thing, and then I'm going to show you something else.
So you have
Good. X and Y, 1, 2, disjunctive syllogism. Does everybody see why that works? Again, those shapes are variables for well-formed formulas. So that entire thing, X and Y, could be triangle. Don't think again just in terms of shapes, but think in terms of the content. The left-hand side, the right-hand side, or whatever. Okay, so now, what is the meaning of 5? Like, what does 5 mean?
We have that,
it's part of the conclusion, sort of, or
Well, it is part of, it's something that you've proved to be true, yeah. But what does it mean for it to be true?
so we don't have J, so we have the X and Y.
Okay, good. Yeah, that's how we did disjunctive syllogism. And then what's the meaning of X and Y?
means we have both of those things.
Both. So couldn't you assert those both individually? So if you put 6, wouldn't it make sense to just say X on 6 from 5?
And would you, is there a rule for that, or is it just?
Yeah, it's called simplification. You could put simp. I call it the simp rule. Does that make sense? How you're doing X and Y? Well, you have both of them, so I could also just split them apart and say 1. And you could do the same thing for Y. Yeah.
Is that a necessary part?
For some of the problems, yes. Yeah. But I'm just introducing it because you're the smart honors class, and this is one of the rules you'll learn next time in 7.2.
Could you also state it as, and I don't know if this is helpful or not to say it like that, but could you say X and Y and not S? Because we've
yeah.
derived all 3 of these.
Good. And now you're just combining them back together, right?
Yeah.
So erase not S and just put X and Y. Oh wait, actually, that would be 5 and 4. Does that make, you're combining 5 and 4? And that's called the conjunction rule. Wow, we're already halfway through the rules for next week. Good. But see, that's what I mean. Some of them are like very simple. And that the conjunction rule is just saying, well, you can combine, if you have a bunch of individual things, you can just put them together in a conjunction. You know they're all true. That's simple. Just like the simplification rule says, if you have 2 things in one that are both true, you just break them apart if you need them. Okay, good job. Good. No clapping. Okay, you can clap. Yeah. That's good.
I like that.
It's like a poetry.
That's exactly what I did in high school, and I love that. I miss going to like poetry open mic nights from my past. You had 5, right?
Yes.
Let's do it.
During the pandemic and the quarantines and everything, my siblings and I would sit in our living room and like make up poetry for each other and have like our own little open mic. It was really horrible poetry, so it was just kind of fun to see who would do the first.
That's so wholesome. That's like such an old-fashioned, wholesome thing to do.
It
I
was
love it.
pretty fun.
Me and my siblings would get together and just kill each other.
So our number 1 is in. Our second one is in or F. And then our third one is N to K.
Cool. And you just have to derive something, but what could you derive?
So we do have N. So since it's NRK, can we say we don't have F?
Mm-mm.
So
Think
it's
about-
inclusive.
Exactly, it's inclusive. So you could have both of them. So just having one doesn't rule the other out. Now, what if I then said N or F and not both? Then if you had N, then that would rule out F. Yeah, exactly.
So we're just going to ignore number 2 for right now. So we'll look at 1 and 3. So since we have N, we must have K.
Right. And what rule would that be?
That would be, that'd be modus ponens, right?
Mm-hmm. Modus ponens, good. And again, the important thing is that you get the meaning and then you cite which steps you're doing. I don't care about the names that much. Try to remember the names, but it's not a big deal if you can't. Okay, Sophia, I want you to do this. I want you to erase, well, I want you to erase K,
In 3 or 4?
both. And I want you to, after end arrow, I want you to put K, then not N. And put parentheses around that. Okay. Now, I want you to then erase your line of inference. And the line above it, yeah. And then now in 4, I want you to put K. Okay, now I want you to derive something again.
Well, this seems like a bit paradoxical.
It is paradoxical, yeah. It's flat out, you're going to end up with a contradiction. And you can already see that, right?
Yeah.
3 on its own isn't a contradiction. But what you will get by doing these rules will be a contradiction. Because 3 just says, if I had N, then if I had K, then I'd have not N. So it'd only be if you had N and if you had K, then you get the contradiction. But let's see. So what could you derive?
I mean, we do have N and we do have K.
Right.
So,
Is there a rule that lets you skip steps to get to not N right away?
not right now.
Not right now. Is there ever going to be one? No. You could make one though. The point is, there's 18 rules. One of the other logic books I learned out of in undergrad had 8. But there were combinations of them. You can define an infinite number of rules, just like there's an infinite number of well-formed formulas, right? But for these set of 18 we're learning, yeah, we won't be able to do that. But what could we do? But what I'm saying is, in terms of the content, you're absolutely right, which is important.
So it's hard because I'm sure we would use 1 and 4 together and somehow a 3, but I don't know how we would figure that out right at this moment.
Okay, so let's do 1 and 3. what could you do with 1 and 3?
Well, you can say since we have n, we must have
Exactly.
parentheses.
Gotta have that whole thing on the right.
So that'd be 1, 3, and modus ponens, correct?
Modus ponens, beautiful. Okay, now what can you do?
So could we put 5 and 4 together?
Mm-hmm.
But what would that give us? That would give us not in?
Mm-hmm.
And again, that would be modus ponens.
That'd be modus ponens, good. Now if you have not in, what can you do with not in?
You could either put it in 2, you could put it with 3, or you could look at 1 and be like, it's a contradiction.
Yeah, you could look at 1, right, and it'd be a contradiction. Let's look at 2. What would you get with 2? 2 and 6.
With 2 and 6, you would get. It could either. Well, we don't know if we have F or not. We don't know.
Just from 2 alone, we don't know if we have that.
Yeah.
Right? But, so what's the meaning of 2? What's 2 mean?
N or F.
Right, at least 1.
Mm-hmm.
So then what's 6 mean?
We don't have N, so would 7 be saying we do have F?
Yeah. And what rule is that?
What rule is that?
You can look on the board, it's okay.
I like my notes. They make more sense to my brain. Would that be modus tollens?
Mm-mm. What operator is used with
Oh,
modus
it'd be
tollens?
disjunctive.
It'd be disjunctive syllogism, yeah. Good. Perfect. Okay, so now look how much you've derived just from me changing like 1 or 2 things. Okay, but here's the point of doing all this. You got a contradiction. Let's say my conclusion is F, though. Isn't it valid?
Yes, because that conclusion wouldn't be affected by the contradiction.
Right. The conclusion, an argument that has contradictions in it is not invalid. Because what's the definition of validity if you think back to a truth table? Whenever the premises are all true, then the conclusion follows. If there's a contradiction hidden in the premises, those premises can never be all true. Does that make sense? So it can never be invalid. So technically it is valid. You just prove that F follows from those premises. But what's the problem with it then? It's not sound, right? Because what soundness is it has to be valid and it has to have all true premises. So if there's a contradiction in the premises, they can't be all true. Does that make sense? So validity is a very technical, logical notion. It is not. You can use validity to discredit people's arguments if they're bad at arguing, and you can use validity to prove to yourself that you're reasoning in a good way. But the important thing to actually settle arguments, settle disputes, settle debates will be then to move on to soundness, right? Because validity can't even criticize somebody for having contradictory premises, right? That's why that two-step approach, is it valid, is it sound, is super important in any sort of debate. Okay, good job, Sophia, that was great. Everybody can clap for her, that's fine. Okay, that's enough. Yeah, that's it, that's all.
I don't deserve it. No.
Yeah, it's true. Who wants to go next? You had 8? You had 3? Let's do 3 first then. Go somewhat in order. Good. Okay, great. 1, 2 hypothetical syllogism. Good. And put 3 on that, just for clarity. Okay. Good. Everybody see why that works? Okay. Now I want to modify this like we've been doing. So I want you to add on the end of R then B, instead of D, I want you to put P then H in parentheses.
P then H?
Right, good. Okay, now what follows from those two, 1 and 2? Good. Right, exactly. Okay, so now I want you to do one more thing. I want you to go add another premise. It doesn't have to be numbered perfectly. Just somewhere up there, add another premise. Just call it 2B.
Okay.
Yeah. Okay. Now in 2B, I want you to put not H. And then I want you to do 2C. And I want you to put E. Okay, I want you to derive, I think, at least 2 more things now. Using 1, 2, 2B, 2C.
Alright. Well, from this one, if we don't have H, we don't have P. Or, yeah.
Yeah, so you're seeing a modus tollens right now within that big thing, right? But technically that doesn't follow the form of that, right?
Okay, yeah.
Does that make sense?
Because we also have the E here.
Right, yeah. So you're right in terms of content. If you did that on a test, and what would you end up getting if you did that?
Get not P.
You get E then not P.
Oh,
Is that,
okay.
because you're doing it within that chunk of it, right? If you did that on a test and said 3, 2C, E then not P, I'd be like, wow, that's good. You're not following the rules, but that makes total logical sense, and that's great. But let's just stick to the rules for now. What's something you could do more straightforwardly that follows that pattern?
Let's see. So we have E,
Mm-hmm.
which means that we have P then H.
Beautiful.
So you can say P then H here. That'll be 2C and 3.
Good.
That'll be MP.
Good.
And then 5, you can do not P.
Modus tollens, yeah. From 4 or 5 modus tollens, good. Wait, I'm sorry, it'd be 4 2B. Yeah, you're right. Good. Okay. Any questions on what we did here? How we kind of broke it up into little chunkies? You know? We good? Okay, let's see number 8. Good job. Yeah, good job, Dylan. Good job, Jillian, is what I said. You can clap for him, that's fine. Okay, that's done. Over. All right, number 8.
I already did it on my computer.
That's fine by me. You just copy it down and explain it, and then I'll toy with it.
Okay. S then J. Sorry, S then W. Not S.
Okay, yeah, look at that.
Okay, so first thing I got was, oh yeah, I got not W.
Mm-mm. Doesn't work.
Doesn't work.
You're doing modus
So,
ponens?
would
or-
it be- the reason I got that is because S leads to W, but then not S. But,
Right. So S is sufficient for W, right?
right.
But does that mean that S is required for W?
No.
No, right. So just because you don't have S doesn't mean you don't have W. Does that make sense?
Yeah. that makes
Yeah.
sense.
So you've got the two valid moves
I
are
know
to.
I can do in for sure.
Yeah, that's absolutely right with disjunctive syllogism, yeah. The two moves that you can do are you affirm the antecedent, the left-hand side, or you affirm the consequent, the right-hand, or you deny the consequent, the right-hand side, which is most ponens and most tollens. But common fallacies that people commit are you deny the left-hand side, like you just did, and then that means you deny the right. That's a fallacy.
Okay.
And
But the right can still exist without the left.
right, exactly, yeah. But the left can't exist without the right. Does that make sense?
Yeah.
Yeah. Man, I really need to dig up the study because I've mentioned it several times already. There is a study that shows that people almost equally amount of the time use modus ponens and the fallacy version, which is denying the left-hand side, and they're denying the right. And human beings, like, just equally use them. So, it's weird that we just think like that. But, so that shows you that logic isn't purely a description of how we do reason. It's somehow normative, how we should reason. And that's mysterious. Ooh.
Is there anything I can draw from this first one?
No.
That's just there.
Yeah. So 4 will be 3-2 disjunctive syllogism, right?
Oh, yes.
Yeah, cite that on the right. And then I'm going to modify one after you're done with that. Okay, so now I want you to put, let's see, how do I want to do this? I want you to put a negation next to the S on 1. Yeah, just negation S then W. Good. Okay, now what can you do there? Right. Well, I can't see. Did you put W?
Yeah, I'm gonna put that way.
Okay, yeah.
And that would
Okay.
just be, can't remember what the name of that would be. Oh, you have it up there.
Yeah. So MP, good. Okay, now I want you to add premise 3B. And I want it to say, if n, then, so n then T or V. Good. And then I want you to do 3C. And 3C will say, not T. Now I want you to add 3D.
Okay.
And 3D is going to say W, then X. Okay. I want you to derive the conclusion. You put 2 slashes next to 3D to mark a conclusion. So like 2 diagonal slashes, if you remember how the book writes it. I think the book does that. I want you to put X and what else do I want to prove? V. I want you to prove that from premises. I know it's a little bit lopsided, but we can all see what's going on.
I
Right?
can tell. Okay.
Yeah.
Okay, so 4 is obviously still good.
Yeah.
N is also still good.
Good. What lines are those from?
That's 2 and 3.
Good. 2, 3 disjunctive
That's
syllogism.
DS, yeah. Okay. So then, T or V.
Good. Yeah. What lines?
3 and 3B.
Good. Well, 3 and 3B? No. It would be 5 and 3B.
Oh, I see.
Yeah, does that make sense?
Because I have N. Yeah, you're
Right, yeah. But you saw it, you were correct.
Yeah.
Good. Okay, what next?
That would be DS also, right? Or no, that would be
No.
MP.
Mm-hmm, MP.
Okay, well, we know it's not T, so it would have to be V.
Good, V. What rule is that?
That's going to be DS. And
Good.
that's also lines 6 and 3C.
Good. Okay, good. So you've got V.
Oh, we
Now
have
what's your
V,
conclusion?
X and V.
Yeah, so you got to get both of them. How do you get both of them?
Well, we need to go, X is just going to be 4 and 3D. Lines 4 and 3D.
Good. Yeah, 4 and 3D. Beautiful. Okay, and then we don't have this rule yet. But you see that you already have your conclusion now, right?
We don't have a rule for this?
Not yet. So, but you've got, no, you do have one that you just did on 8. Yeah, that's just modus ponens.
Okay.
Yeah, MP. But your conclusion is that X and V are true, right?
Yes.
Now, you have that content on 7 and 8 already, right?
Yeah.
So, fast forwarding a little bit, because it's a smart honors class, you can just combine 7 and 8 into one thing, just X and V. Does that make sense?
So I could just, in the future, I could only have 7? Or would I make a new line 9 and then have 5?
It would be 9, and then it would be 7, 8. So you'd write 9? And then you go X and V. 7, 8 conjunction.
See?
Yeah, you do C. You do conj, whatever works. Yeah, I don't care. And the point of that is, again, if you know 7 says V is true, 8 says X is true, so you could just put them together and say both are true, right?
Yeah.
And there's your conclusion, right? You just did a great proof. I mean, that's a full proof. The first full proof of the class, everybody. He did it. Every class. Yeah. Good job.
Can we erase?
Sure. Okay. Does everybody see how natural deduction is working? Kind of? A little bit?
I think today I'm just frazzled, so maybe on my own, working it out on my own.
You seem like the type of person who sits down and learns things on their own the best, yeah. Which I completely, I'm the same way. I learn almost nothing from being in classes. Until I have questions from doing it on my own, and then the teacher's there to answer my questions. But I don't like lectures. Okay, questions, comments, concerns, anything at all about this? What time is it? 2:14?
242.
Oh, 2:42. I was like, it's only 2:14. Okay, we can call it there if you want. We could do more problems. Anything? Okay, again, we've already learned half of 7.2, so go ahead and start on that. It's the same thing. And the warning I will give is that all of these rules are cumulative to the end of the semester. So how the test is going to work, in my great mercy, I have split the third test into 2 parts. One part will cover the first 8 rules. The second part is going to cover all the rules. Cumulative. But at least you'll be able to score points on just the 8, right? Any questions, comments, concerns, insults? We good? Okay, class dismissed.